Hi, my name is Fabrice TROLLET and I am the MaTeLo Product Manager at All4Tech. Welcome to this MaTeLo Tutorial Session 2. You are going to update the model you designed in the Session 1 and learn how to create subchains, dynamic calculated data and explore all MaTeLo generation algorithms. We go back to Edition View to continue the design. We are going to see what happens when the vehicle goes faster than 50 km per hour. Double-click on a state, which becomes a macro state and which automatically creates a chain. You can also create it manually on the left part. The state is linked to the macro chain, which is called higher than 50 km per hour. In this macro chain, we create the system behavior when we are higher than 50 km per hour. The first time we come into this subchain is the default cruise control disabled state, and we can directly exit the disabled state to come back to the parent chain. Next, go to another state called enabled. Create a transition to push on the main button, the cruise control button, the one in the middle, which allows to go from disabled to enabled. When you press again, you go from enabled to disabled. To sort your model, use the small system icons at the top of the screen to sort the different states and transitions. Then, exit disabled with a transition which allows to go back in the root state. Create another macro chain enabled by double-clicking on Ine state. We create here both possible user action set plus and set minus. To go to set plus, you have to press on set plus button. Then, check that the speed really increased. To proceed, add a verification check speed, and this time don't use directly the variables because you are going to use a treatment function to calculate the output. Go to treatment function and right-click on treatment function library folder and create an add function. Then drag and drop this treatment function on the verification pre-treatment function folder and set E parameter to external check speed value and set 10 km per hour to the B parameter. Return this result in the output transition check speed. Now, create the transition to push the set minus button and the transition to check the speed when set minus is pushed. Here, there is a trick. You cannot go slower than 50 km per hour. If you are close to 50, for example between 50 and 60, if you push set minus, the vehicle stays at 50 km per hour. And we use this time another treatment function, which is an Excel function. Very easy to use as you don't need any Excel sheets. You directly write in English the Excel formula that you need. This function is also located in the treatment function library. It is called Evaluate Excel Formula. There are 3 parameters with the option, when a star is indicated, to add as many parameters as you wish. Here, in value, there is only one input parameter. Click on New Child varag item. Write this Excel formula in English as following: equal if, with parentheses, if the latest value square bracket 0 replace cells like R1 or B2 by square bracket is slower than 60 km per hour, you should get 50 km by hour. As you cannot go slower than 50 km per hour, else keep the latest measured value, remove 10 km per hour, and this will be the result. At the end, the check speed is automatically created. We are now create the pattern for disable state by double-clicking on disable state and transform it as a macrochain. There are also two options. First, click on Set Plus. Create the transition to push on Set Plus button. The difference compared to enabled state is when you push Set Plus, the speed shall not increase. You got now Set Plus and Set Minus. You reach the Set Minus state clicking on Set Minus button. The expected result is defined in the second transition. Check now that the speed didn't change. Write check speed and the expected result is the latest measured speed. You don't need any treatment function here as you directly indicate it in the interface. Proceed the same way for Set Minus. The speed shall not change. Choose for check speed the latest measured value equal to. In this project, we don't use the higher boundary. Generate again the project in minimum arc coverage. Don't forget to select all chains which are not ticked in the Chain tab. With the minimum arc coverage algorithm, we got 25 transitions and 23 steps. Open in HTML thanks to the HTML Viewer tab. Double-click to display the test case in full screen. The speed increases at 129.69 km per hour, and this time when you push on Set Plus button, the speed increased to 139. We really increased the speed by 10 km per hour. Then you go back to displayed and pushing on Set Minus. We stay at 139. Push again on enabled, then on Set Minus and you go back to 129. We can see a small mistake here as we didn't remove the boundaries, so correct it now in the model. At the next generation, it will be correctly displayed. Set equal to and remove the lower boundary. You are at 129 and you go back to disabled. Push on Set Plus and you stay at 129. To exit the test, the vehicle shall slow down. Stop the vehicle and turn off the engine. Let's continue the model to design another requirements. Normally, when you push on resume, nothing shall happen in this context. The speed shall not be resumed as the system is disabled. In this transition, you press resume. And the other transition is not a step. It just comes back to disabled state and nothing happens. You can also offer the option to change the speed when the system is disabled. It is the driver who is going to accelerate or decelerate as he wishes. You still drive faster than 50 km/h in this case, or the enable button will not work. We could also use a condition at this step. Change the speed and indicate that the expected speed shall be equal to the latest measured speed. Then go back to disabled. Sort the model to make it straight using the relative icons to sort the states and transitions. It is somehow similar to what you can do in PowerPoint. Then, design the states when you want to cancel the speed. You are on Enabled and you push on Cancel button, C and C. This button is used to come back in an intermediate state between disabled and enabled states. If you push on Resume in this situation, then you go back to the initial speed. Press Cancel button and in Cancel, create a Macrochain double-clicking on the state and save the latest measured speed. It is not really a test step, but keep it as is. You could remove it as the tester doesn't need. It is only for MaTeLo. We save the cruise control speed in a global variable. Create an assign treatment function and create a global speed value in Data tab. Link this assign treatment function on the transition with the aim of saving the latest measured value. Save it in the global variable to use it when you press Resume. When you are in Cancelled, you can change now the speed. Even if you are in the higher than 50 km/h Macrochain, you can change the speed as you reach among all possible speed ranges. So keep 0 to 50 and 50 to 150. You can stop the vehicles when you brake, you can do whatever you want. Then, set that the measured speed is the one you just defined. The cruise control speed is not used anymore. Now create a new state as when you push on Resume, the vehicle shall resume the initial speed of the cruise control. You could have only one transition, but we do it to make the model easier to understand. Push on Raise button and go to Enabled state. On this transition, add a check speed. Click on the transition and write check speed. And set the speed value with the one you previously recorded. So, check speed is equal to the global variable that you previously defined. Again, the lower boundary is not used. Just to show you that we can also use timings in MaTeLo, and because it can take some time to resume the speed, you are close to 0. So when you press resume, it will take some time, so set it to 30 seconds. You can also handle this with variables and formula to get something more dynamic. You can also create some delays before and after. Now design the clutch pedal mechanism. When you press on the clutch pedal, you get the same behavior as if you press on cancel. Add a transition to press on the clutch pedal and then go to the cancelled state. On clutch state, set the same macro chain as you use for cancel. You are doing some model reuse. The cancel mechanisms use the same cruise control speed. They are the exact same macrochain. It is not a copy-paste. It is the same macrochain which is used. Now, create a new state called brake. Add a transition to define the brake stimulation. Press on the brake pedal. You will have the same behavior as the clutch pedal. So link it to the cancel macrochain with the aim of going back in a cancelled state. In these three states, you have the same behavior with the resume button. Go to generation perspective and generate in minimum arc coverage. You got now 49 transitions and 45 steps. Open the HTML view to check that the test is consistent. All other requirements will be implemented later. You can see all speed values, 137 at the beginning, then the speed doesn't increase as the system is disabled. Then you go in enabled state, you push on set plus button, and the speed increases to 147. You push on cancel and the speed is changing. You slow down at 5.89, so a very low speed. You push on resume and after a 30-second delay, you go back to 147 km/h, even if you were driving at only 5.89. From 147, you push again on set plus and the speed change 157. You press on the clutch pedal, then on resume and you stay at 157. Pressing set minus, you slow down to 147 km/h. You press on the brake pedal and you stay at 147 km/h when you press on resume because you didn't change the speed. With other algorithms, MaTeLo could change it. Using user-oriented, you could have several loops to change the speed. We will go back to that. Then you go to disabled state. This time, the current speed of 157 km/h doesn't change when you press on set minus, as the system is disabled. The speed changes to 123 km/h, and finally, the speed is decreasing and you stop the vehicle. Add a check speed on the transition to go back to disabled to indicate that the resumed speed is equal to the latest measured value. We forgot it, which is not so important. At the next generation, it will be correctly displayed. Let's continue to design the model. In the less than 50 km/h state, you can also directly reuse the disabled macrochain. Double-click on the state and you can see that it is the same disabled state as the one you use for higher than 50 km/h. You can do the same for the cancelled state, linking it to the disabled macrochain. It is not a copy-paste in MaTeLo, but for the algorithm, it is a copy-paste. When you are using a macrochain containing several transitions, MaTeLo will pass each time for each iteration on these transitions. Now remove the useless test steps to have clean test cases. In the left part, in the Project Explorer, you can see some dashes, minus. Every time there is a dash, it means that there is an empty test step. You can double-click on them to see their relative transitions. If you untick the step on the transition, it will automatically create during the generation some test cases without any empty test step. The added value is if you perform manual testing activities. You will not be impeded with useless test steps. Don't hesitate to remove all empty test steps in your model. Generate again in minimum arc coverage, selecting all chains. We got 65 transitions and 57 steps, with some indicators that you can display clicking on this icon. This displays the coverage of transitions, equivalence classes, states, and the combinations of all of them. You can now use another algorithm, for example most probable, which generates in priority the test cases that we wish. On this transition you got a probability of 25% in the profile tab, so you have a 1 in 4 chance, as they have 4 outputs from the less than 50 km/h state. If you want to go more often in the accelerate higher transition, just set a higher probability. If you choose often, there is now 20% for others, while it was set to 25% before. If you generate now in most probable, and if you ask for 10 test cases with a decreasing rate to obtain from the most probable to the less probable among these 10 test suites, you are sure that the first one is passing by the accelerate higher than 50 km/h transition. As this test suite is quite big, it will take some time to obtain it. The decreasing rate of the most probable algorithm makes sure that each time MaTeLo is passing in a transition, it will change the probability to 0% and will distribute its probabilities to other transitions, for they can have a chance later to get through. You can see here that it is passing by the transition that you increased odd. You can check the whole test, but as you didn't set any custom probability in this model, you just set 1. But if you want a specific pass, you can add higher probabilities on the transitions that you wish MaTeLo to get through. The user-oriented algorithm is used to generate in a statistic way more test cases with the transitions with higher probabilities. Generate 10 test cases and you can define the maximum length of these test cases. If it is longer than planned, it will be deleted. If the test case is displayed in red, this means that this pass already exists. For user-oriented plus filter, it is like user-oriented except that you can filter on the test case previously recorded, or those of your projects if you tick the including box. If you filter on transitions, each time a new test case is generated, if the new test case doesn't increase the transition coverage, it will not be displayed, it will be delayed. Try with many attempts. By default it is 100 to generate a new test case which can reach a new transition. Random algorithms allow us to generate completely random test cases without taking into consideration your profiles. Target path is used for manual testing with the aim of regenerating with MaTeLo some specific paths. Finally, path coverage algorithms can automatically generate all the possible paths in your model. This algorithm is mostly used when you don't have many loops and no condition in your model. As in your model, there are many loops, so many possible test cases, probably few thousand test cases, and they are all different. Here, we stop at 340 test cases, pressing on cancel and asking to generate all test cases already created. All these test cases will be different with a probability of different passes, for example 10 power 59. If you have any question, feel free to ask them directly in the video comments. To be notified of our future MaTeLo videos, please like this video and subscribe to MaTeLo channel. And don't hesitate to connect and follow me on LinkedIn.